Okay, let's start with our module number 4. This is the intended learning outcomes. At the end of this module, you should have and be able to do the following. Number 1, analyze the concepts of object-oriented programming using Python and differentiate the OOP or object-oriented programming from classical and traditional. Number 3, develop a program using class and object. And then understand the concepts of inheritance, abstraction, encapsulation, and polymorphism using Python. Also, develop a program using different types of inheritance, abstraction, and encapsulation. And finally, you should be able to develop a program applying the concept of polymorphism. So, module number 4 is all about, actually, it's a combination of module number 4 and number 5. Now, I will be advancing the topics since object-oriented topics are covered in module 4 and module 5. However, since you do have a project to submit in module number 6, at the final week, you should be able to understand also how we can create programs using graphical interfaces, and I will be discussing that when we return after the holiday break, and that is with module number 5. However, in this module number 4, I'll try my best to discuss all the topics related to object-oriented programming. So let's start. Okay, if you have some questions, you can use your microphone or you can just chat in our public chat, and if you have some questions regarding our topics. Okay, so let's start with discussing about object-oriented programming. Alright, so Python is a multi-paradigm programming language, meaning it can be Python can be used for many models or many formats of programming language. So basically, it supports different programming approaches. You can use Python in traditional programming. You can also use Python in other methods of programming, such as object-oriented programming. And one of the popular approaches to solve a programming problem is by creating objects. And when we say creating objects, you will understand later the concept of the objects in object-oriented programming. This is what we call the object-oriented programming, or in abbreviation, we can call it OOP na lang, so that we can understand what OOP is all about. So when we talk about OOP, that means object-oriented programming. Now, talking about the objects, an object has two characteristics. Number 1, any object has an attribute. When we say attribute, we call it the characteristics, the traits, okay, the qualities. So that is what we call attributes. The second is the behavior. How does the object behave? And any object, including man, animals, trees, any object in particular in the real world, we have these two characteristics, that any object has an attribute and any object has a behavior. So, for example, a parrot can be an object. Okay, so it's an animal actually. It's a bird. And it has the following properties. So a parrot can have a name, age, and color, and this age, name, and color are all what we call characteristics or attributes or traits. Now, a parrot can also have a behavior, such as a parrot can sing, a parrot can also dance, a parrot can also talk, for example. So those are the two characteristics that a certain object, like in this example, we have the parrot. It can have both those characteristics, such as the attributes and the behavior. The concept of OOP in Python focuses on creating reusable code. No? That's why many may ask, sir, why do we need to use OOP? Well, the concept of OOP is to be able for us to create codes that we can use later on, no? Rather than scratching or starting from the scratch, or starting from zero all over again. So we need to understand that when we create an object-oriented programming program, we can actually reuse the code over and over again. And this concept is also known as DRY or dry, which means don't repeat yourself. Okay? Because many new programmers, they tend to repeat the lines, the codes that they are using in their programs. And the concept of object-oriented programming avoids us from doing such things. Okay? In Python, the concept of OOP follows some basic principles. And what are these principles? Number one, we have the class. So remember, this is a class. So what is a class? A class is a blueprint for the object. No? So we can think of a class as a sketch of a parrot with labels. Okay? And it contains all the details about the name, the colors, the size, etc. Based on these descriptions, we can study about the parrot. No? Here, a parrot is an object. So an example of that, so I guess we can create a class of the parrot. So how do we create a class? We use the keyword class, okay, here, and then the name of the class, followed by a colon symbol, and then followed by the statements underneath the class. Now here, we use the class keyword to define an empty class parrot, no? And from the class, we construct instances. Now inside it, we can create some instances. What is an instance? An instance is a specific object created from a particular class. You will understand this later on when we give some examples. Okay? So we said that when we create a class, we can create instances of the class, and those instances are what we call object. And what about an object? And what is an object? An object is what we call an instance. No, when we say instance, okay, it's what we call instantation or instantiation of a class. When we define a class, like in this example, we define class parrot, only the description for the object is defined. Therefore, no memory of storage is allocated. And the example for object of parrot class can be like in this example. No? So we use this obj or ob or obj. This is what we call an object. Okay, when we try to equate it to the class parrot, no? We're using the parrot and then the open and close parentheses here. No, it seems like when we create a class, it's like a method. No, okay, we are creating a method and then we are instantiating a method. Okay, but actually it's not a method, it's called a class. No, so here we instantiated an object, we call it obj. It's an object of the class parrot. No, so this obj is an object that now belongs to the class parrot. No, suppose we have details of the parrots, we can now show how to build the class and objects of the parrot. No, so this is an example of how we can create a class and then we can instantiate object using Python. No, so as we have declared a while ago, we created a class called parrot, and then inside it we can instantiate objects. No, like in this example, we instantiated some class attribute. No? So we call attributes as the characteristics of the objects, right? So this is a species, we equate it to the bird, okay, which is equal to bird. And then after that, we create an instance attribute. No? So this is an instance of this attribute that we have created. No? So for example, we have here define and then double underscore init and then double underscore, and then we call inside the parameters self, right? Self, name and age, and then we call self, and then we use the dot and then the name, which is the parameter that we use here, okay, and then we equate it to the name as well as the age. Self.age is equal to age. So in this program, we have created a class called parrot, okay, and then we define attributes. The attributes are the characteristics of an object, and these attributes are defined inside the init method. Now we call it, when you see this one, we define an init method, okay. It is the initializer method. Now we call the init or the initializer method that is actually run first as soon as the object is created. Okay, so when we create the object, this initialization method is run first, no? Then we create instances of the parrot class, no? Here, we created the instances of the parrot. We have the blue, okay, which is equal to parrot, and then we instantiate the name. This is the name because of this one, no? Because of the instance attribute. Okay, so when we declare an instantiation of the parrot class, we declare this object blue. Okay, we declare this object blue to belong to the parrot class, and it has a name of blue and an age of 10. Also, we added woo, no? And what is this woo? Woo is now belong to parrot class with a name woo and an age of 15. Okay? So here the blue and the woo are references value, okay, to our new objects. So these are our new objects that we created. Now you can access, we can print or we can access the class attributes of the parrot class using the blue and the woo, no? Using the attribute, the class attribute. Actually, this is a class attribute. This one that I highlighted, the underscore class underscore dot species, okay, because they belong in the species, okay, which is a class attribute of the class parrot. Okay, so we will know now, based on this, when we try to print this one, we will know what class attribute does our blue object belong to. Okay, for example, blue, what is the class dot species of the object blue, and what is the class species of the object woo? So this is how we are going to print that, no? So we have the blue is we have we call it, this one is a special holder, no? Is a holder that we use for a variable or something, right? And these class attributes are the same for all instances, no, of a class. Similarly, we access the instance attributes by using blue.name. This is how we can access the instance attributes. So basically, we can access the class attributes, and we can also access the instance attributes. So, okay, so we can access the class attribute, and we can also access the instance attribute. No, we can definitely see the name and the age of every object that we have created for the parrot class. All right, so this is the format for accessing the instance attribute. You can see that there is a dot format here, no? This is a method wherein we can actually print using a placeholder here. Okay, this is a special placeholder where we can put the parameters, no, that while we are calling these parameters here, they are being placed here inside this placeholder. So right now we're accessing the instance attribute, the name and the age of the blue object, no, and as well as the name and the age of the woo object. So when we try to print that, this is the result. Okay, so blue accessing the class attribute, we know that the class attribute of the species is bird, right? So when we try to access the class attribute using class.species, blue as an object belongs to the bird class attribute. And at the same time, woo is also a bird. No, it belongs to the class attribute. And blue, like in this example, we access the instance attribute. We printed, we have two placeholders. This first placeholder is dedicated for this first instance attribute, and the second placeholder belongs to the second placeholder or second variable, or what we call an instance attribute. So basically, so blue is 10 years old, and then woo is 15 years old. All right? So basically, that's how we can identify, how we can create a class, and then we can instantiate objects inside our class. Okay? So again, let me try to explain again. What are the things that we can do? We can create a class, and we can create class attribute inside our class. We can also create instances, instance attribute using the initialization method or initializer method. When you use initializer method, we always put the self, no, as the first parameter. Okay? And then followed by the additional parameter that you want to use. Like for example, in this case, we want to use name here, and we want to use age here, no? So you can also rename it to other things, no? In any variable that you would like. But make sure when you call this instance attribute, you need to specify the correct names, no? Because Python will not understand if you use other names, no? Or if you mix up the names when you try to access the instance attributes of our class. Okay? Now let's try to create methods. Okay? And what are methods, by the way, no? So basically, we understood about creating class, and a class is a blueprint for the object, and then we also discuss about object. This is the instantiation of the class, or we call it the instance of a class. Now, what is method? No, methods are functions defined inside the body of a class. So basically, we can also create how the behaviors are defined, no, for a particular object. No? Like in this case, we are given an example here to create methods in Python, no? So for example, you can see from here, this is another example. We define two methods actually here, no? So this is the instance attribute. We use the initializer again, no? We use the initializer declaring self, name, and age, no? So this name and age are all given here. Self.name, self.age. Now we have created here two methods, no? Two methods. And what are these methods? So we define those two methods, no? The first one is define sing. Okay? So inside the parameter of the sing, we also call the self. Okay? So we call the self and the method, no, which is song, for example. And then what does it return? It returns a placeholder that sings a placeholder, no? So we are calling the self.name and the song. Okay? And then another method here, We call it dance and then self. And then we return that method by accessing the name, no? The name of the method. Now, actually, the name of the method is dance and sing. So when we instantiate the object, okay, so for example, blue, and then it belonged to the class parrot, no? So when you try to instantiate an object, make sure to use the class name, okay? So these are called instance methods because they are called on an instance object called blue, as you can see from here, no? They are all called on an instance blue. So when we call our instance method, actually we use the blue object and then we use the instance method, no? So blue, sing, and then we inserted, because there are two variables here, we can also insert something inside, no? But here, since there are no other parameters in the dance, so there is no longer need to put additional parameters inside this. So when we try to print this, okay, so it will give us an output of blue sings happy and blue is now dancing. So if we try to delete, for example, no, let's try to delete this, okay? So what will happen if we delete the parameter that we place here, no? For example, so it will give us an error that says the sing instance, no, that we created here, the method sing, is missing one required positional argument, which is the song, no? So actually, yung self dito, hindi siya nakikita. It's actually built in, no? Built in siya. But the song here is a parameter, or we call it a positional argument that is required. So we need to put something inside, like for example, happy or sad or sing beautifully, for example, or any other adjective that we can describe, or something that we can put here. Okay, so when we try to print this one, it will now perfectly gives us the result without any error. But by the way, can we put something here? For example, can we always also put happy here? So when we try to print this, it will also gives us an error indicating that the dance instance, okay, instance method, it only takes one positional argument. But this time, we have two. We have the self argument, okay, the self argument, and we added another string here indicating that we have actually gave the instance two positional argument. So definitely hindi natin to dapat ilagay dito so that we can have a perfect result such as this, no? So we have to be careful, no? When you declare an instance, remember to count how many arguments or positional arguments that you are creating. Also here, no? Also here. Remember to declare all the positional arguments here, no? As the self.name and the self.age. So that when you call it, no? You will know that the program that you are creating will not give you any other error, no? Okay, so another concept of object-oriented programming is what we call the inheritance. Now we will study about inheritance a little bit later, but this is just a background of the term inheritance, no? Now in inheritance, so that you will understand it clearly, okay, inheritance is a way of creating a class. Okay, you are creating a new class for using details of an existing class. So dito sa taas, we have created a class, right? What if we create another class, okay, and we do not modify this class That means we are not changing this class, okay? We are not changing this class that we have created. So basically, we can do that, no? We are trying to create a new class, and we are using the details, no? The details that we have placed here, no? For example, instance attributes and instance methods. The details that we use in our class, we can actually use those details of those existing class without modifying this class, these attributes, okay? Or details, no? Now, the newly formed class that we created is now what we called a derived class, or what we called a child class. So remember the terms, kapag ka nag-create tayo ng class and we took the details of an existing class, the newly formed class will now be called derived class or child class. Similarly, the existing class is what we now call the base class or a parent class. In this particular example, no, in this one, no, creating methods in Python, this is what we call the base class, no? Okay, this is what we call the base class, but it cannot be called a parent class since wala pa tayong kine-create na child class. A parent can only be a parent if it has a child. Okay? So, in real life and also in object-oriented programming, it's somehow can be explained through that, no? So, basically, we can use inheritance in Python wherein the details of that means, as an example, no? For example, you have a father and you have a mother and you are a child, right? Some of the attributes of your father, you can take those attributes, no? And that makes you as a child of your parent, no? For example, you took the eyes of your father, and then you took the nose of your mother, and then you took the complexion of your grandfather, etc., etc. So that is what we call inheritance, no? You're inheriting the attributes or the details of your parents. So this is basically the same when we use inheritance in Python, no? So basically, when we do that, we create a parent class. Like in this example, you will see we have a parent class here, okay? We have a parent class. So here we created two classes, okay? The first class is class bird, and the other class is class penguin, okay? So you can see here that the bird is what we call the parent class, as denoted by the comment, no? And the penguin, okay, not only denoted by the comment, but you can see inside the parameter of the penguin, this class penguin belongs to the class bird. Okay? So therefore, this is a child class because it belongs to the parent class bird. Okay? So the child class will inherit the functions of the parent class. What are the different functions here? The initializer method, and then we have the function who is this, and then we have the function swim. Alright? So these functions, okay, the child class will inherit the functions of the parent class. So we can see from the swim method, okay, from the swim method, that the swim method can definitely inherit by the child. So the child class tries to modify the behavior of the parent class, no? So we can see from the who is this, okay? So who is this? It prints penguin, no? It's not printing bird, but it's actually printing penguin. Alright? So we can also extend the function of the parent class by creating a new run method, no? Here we created another method, and this is also particular not only to the penguin class, but also to the parent class, which is the bird. Okay? So additionally, we use the super function here. Okay? You will notice that we use a super function. So when you see super and then there's a open and close parentheses, that's a super function. No? It's inside the initializer method. Okay? And this allows us to run the initializer method of the parent class inside the child class. So using this, we are actually, using the super function, we are actually running the initializer method of the parent class. But here we declared super function and then initializer method, and then we print something here like print penguin is ready. Alright, so the output of this, when we try to instantiate an object of the class penguin, okay, so you will see here that Peggy, okay, Peggy dot who is this, okay, it will print, definitely it will print what? It will print, you can see from here, no, that it will definitely print the functions that are declared here, which is to print bird is ready, print bird, and print swim faster. Okay, so as you can see from here, and then we instantiate also Peggy who is this, Peggy who is this, and we call the function Peggy.swim and Peggy.run. So when we try to execute this, it will print the following output. Okay, so that's the output that we are actually looking for using inheritance in Python. Okay, another concept of object-oriented programming is encapsulation. Okay, so you understood now what's inheritance. We are actually using the details of the parent class and it's being transferred to the child class that we are creating after the parent class. Okay, what about encapsulation? No? Using OOP in Python, we can actually restrict access to methods and variables. Okay, and this prevents data from direct modification, which is called encapsulation. So the concept of encapsulation is this, no? If you want your data not to be changed, okay, you use encapsulation method, and that is also available in a particular OOP in Python. Okay, so from this we can prevent the data from direct change, which is called encapsulation. And in Python, we denote private attributes using underscore as the prefix. No? For example, single, and then we have a underscore, or single underscore, or double underscore. Okay, so that will be the private attributes that we can initialize if we want to denote private attributes in Python. No? So here's an example of data encapsulation in Python, and let's try to understand the following program. No? From the program, since this is an example of data encapsulation, we defined a computer class. Okay, so this is the class computer. So inside the class computer, we use the initializer method, okay, to store the maximum price of the computer, okay, which is 900. Okay, so then after that, we tried to modify the price. Okay, we tried to modify the price. Okay, however, we can change it because Python treats the maximum price, the double underscored max price, as private attribute. So you can see the inclusion of the double underscore here makes this as a Python attribute, okay, or we call it the private attribute. So as explained from here, no? So therefore, this maximum price cannot be modified. Okay? Because this is a private attribute. However, you can change it. You can change the value by using a setter function. No? Using a setter function, we can use set max price, another method, okay, wherein we can modify, okay, we can modify the price as the parameter now. Okay, so this now will become the parameter. Okay, so the self underscore max price will be equal to price, so that we can modify it, which means it takes the price as the parameter. So we have an object here. Okay, we have an object called C, which is equal to computer class, and then we instantiate the method by calling the function or method cell. Okay, so when we call this method, this will give us, okay, this will print us selling price, which is 900. Okay, now when we try to change the price, okay, when we try to change the price and we call again, it will not change yet, no? Because actually this is a private attribute that we cannot change. So definitely the second line here, the second output, the price of the computer is still 900, because we cannot change. Even though we change the max price to 1000, we cannot change this because this is a private attribute, and originally the private attribute is set to 900. Okay, now using the setter function and using the parameter as the price, we can now change the price of our computer by calling the object C and then calling the method setMaxPrice, and inside the parameter we now declare the 1000, which is the change from 900. We make it 1000, and then we call again the function that sell, no? So the selling price will now call, okay, as you can see from here, okay, will now call the following, no? So it will call self that max price. And what is that max price? Using the function set max price, we're calling the price, which is actually equal to self that max price. So whatever you put here, for example, you put here 500, when we try to enter this, the price of the computer will change, no? The price of the computer will not change. But if you make this 500, it will remain 900. So it doesn't change at all. Even if you make it 50,000, it will not change at all, right? Okay, but here, if you change anything here, since it's calling the self.max price, and we put it in our variable or argument price, so whatever we place inside this argument will definitely the selling price for our computer. So let's say 1,500. So our new price now is 1,500. All right. Now another. By the way, do you have any questions regarding our discussions? Are there any questions yet? May mga questions pa tayo from the Do you have any questions? Do you understand the topic?
Sir?
Yes.
Need po ba lagi mag-initialize sa mga class?
Yes.
Yung underscore init, kailangan
yes.
lagi na.
Laging dapat merong initializer method, because the init method is run first during the initialization of each classes.
Okay, thank you, sir.
Okay, basta sundin nyo lang yung mga formats ng mga ibinibigay nating example para hindi tayo maligaw. Pero anyway, very good question, kasi you can see always that the initializer method is always there, di ba? But however, in this case, no, in this particular example, in our next topic, you will not see the initialization, no? Initializer method. From here, meron tayong nakita na initializer method sa encapsulation. Pagdating natin sa inheritance, meron din tayong initializer. Even dito sa ginawa nating first example ng pagkikreate ng methods and pagkikreate ng class, meron tayong initializer method. But here, in our next topic, which is we call it polymorphism, okay? You will not see initializer method here, okay? So let's try to discuss polymorphism if there are no more questions, okay?
Sir, may ibang question po ba po dito?
Question? Sir,
Meron sa chat.
okay, sige, thank you. Sa loob po ba dapat ng code mag-change ng value? So it depends, no? You have to create first from the example that we have created here. Di ba ang ating format to initialize the price is this one, right? If you want to change the price, since ito kasi ay private attribute, so if you want to change this, use another method to do that. Okay? And simple lang yung approach, no? The same here, but definitely the argument that you place here will be the name of the object that you instantiated from this function. Okay? So that will be the case. Yun yung tanong ni Hezola. Sa tanong naman ni Binay, yung ibang parent class meron pong object na parameter. What do you mean by this? Sir, yung ibang parent class meron pong object na parameter. What do you mean by object na parameter? Object. Sa example natin, do you have that in our example? Dito sa taas. Saan yun? Ano kayang ano yun? Yung sinasabi mo, object. I think dito yun sa sa inheritance, yung sinasabi mo, this one. No? This is not an object. This is actually the class. This is the parent class, no? So when we create a child class, malalaman nating child class siya kapag ginamit mo yung pangalan ng parent class mo. So you can see, parang ito yung surname, no? This is the first name, this is your surname. And the surname is this one, no? The parent class. So you inherit the surname or the name of the class of your parent. Okay? So that is the concept behind that. Okay? So, okay, I think we can continue with the polymorphism. Okay? So, polymorphism is an ability in OOP to use a common interface for multiple forms or data types. For example, we need to color a shape, and there are multiple shape options like rectangle, square, and circle. However, we could use the same method to color any shape. And this concept is called polymorphism. So definitely, what is a polymorphism? It is used to have a common interface for different types of forms or data types. So as an example, we have here, para mas clear sa inyo itong polymorphism, we have here an example of two classes, no? So we have the class parrot and class penguin, neither of which are a child or a parent, no? So magkaibang class to. Okay? We have two classes, no? Separate to, hindi to child, hindi rin to parent, no? Because they are not using the name of each other. Okay? Now, each of them, however, you can see each of them have a common method, no? Meron siyang define fly method here, meron din siyang define fly method here. Okay? However, the functions inside are different, no? This is to print parrot can fly, and this one, the function is to print penguin can't fly. Okay? Now, to use polymorphism, we created a common interface. And what is that? The common interface is this one, no? We define flying test, okay, function, which takes which can take any object, no, and calls the object's fly. So we can call the fly. So we definitely have a bird here, okay? So we created a parameter here called bird as an argument, okay? And we put it, and we use that bird to use the function fly method. So definitely when we pass the blue and Peggy here, no, this blue and Peggy for parrot and penguin, okay, these objects in the flying test function will function, no, it can run effectively. So parrot can fly, and penguin cannot fly because of the functions that are declared here. Okay, so we created this common interface. Okay, so do you understand? Do you understand the concept of polymorphism? It's all about creating a common interface between the two different classes. If they have similar classes, okay, if they have similar classes, then definitely we can actually create a common interface, no? In this case, we created the flying test function, and then we instantiate that function using the fly method. Okay, so when we try to pass this blue and Peggy objects in the flying test here, no, in the flying test, we pass this blue and Peggy, it definitely runs effectively. Okay, any question for polymorphism? Okay, wala. Okay, so there are key points to remember. Okay, just try to remember that in object-oriented programming, it makes the program easy to understand as well as efficient, no? It's like maybe at the start medyo mahihirapan kayo because this is a different procedure. Okay, this is a different procedure, but definitely when you try to practice, no, more and more practice, you can definitely understand the concept, no, and you can grasp the concept of creating object-oriented programming. Why? Because the class is shareable, no? You can share the class, the code can be reused, the data is safe and secure with data abstraction, and also polymorphism allows the same interface for different objects, no? So programmers can write efficient code actually. So it's all up to you on how you can do that, no? So these examples are very clear examples of the logic behind the inheritance, the polymorphism, and the other one, which is encapsulation. Okay, now let's try to discuss about Python objects and classes, but before we do that, let's pause for a break. Okay, so let's continue with our discussion. I hope everyone is back after a long break. So let's try to, now that we have discussed about how to create classes, how to instantiate an object, and then how to create instances of methods, for example, and then we discuss about some examples of inheritance, encapsulation, and polymorphism. Let's try to understand more about Python objects and classes. Okay, so basically, as you have learned, and I have also discussed a while ago, Python is an object-oriented programming language. It's not only a procedural-oriented programming, but OOP, unlike procedure-oriented programming, the main emphasis of the OOP is more on functions. Oh. As I am saying, the procedure-oriented programming is more on the emphasis on the functions. However, this is not the case with the OOP, no? Because the OOP stresses on objects, no? Creation of objects. That's why it's called object-oriented programming. So it's focused on objects, not on functions. Now, the object is simply a collection of data or variables. And methods, kapag ka sinabi nating methods, they are also the functions, no? And those functions act on those data or variables. Okay, so we have an example here. We have these objects, okay, and we have the function that we created so that we can basically perform actions on those variables that we have created.
Sir, naka-off pa yung mic niya po.
Sorry.
You are
Naka-off
now
pala,
unmuted.
sorry. Okay, ito na naman tayo. I missed something here. Okay, anyway, thank you very much for your clarification. So as I am saying, after we discuss about the creation of classes, creation of objects, and instantiation of methods, we also discuss about the inheritance, encapsulation, and polymorphism, no? So it's time to discuss more about Pythons and objects and classes. Okay, so the difference between the procedural oriented programming is that the emphasis is on the functions, while in the object oriented programming the emphasis is more on the objects. That's why it's called OOP, or object oriented programming, because the focus of the OOP is more on the objects. So basically, dapat ang matatandaan natin dito should be the object is simply a collection of data or variables. Okay? So when we talk about data, these are the variables, no? Like in this case, this is an object, this is a variable, no? And then we equate it to our class, which is parrot and penguin class. So Blue and Peggy are objects. All right? So, and methods, no? Like in this case, these are methods. They are inside the class. Okay? We instantiate methods inside the class. These are the actions that we could actually create, okay, or functions that we can actually act on our data or variables. Okay? A class is a blueprint for that object. So we can think of a class as a sketch or prototype of a house, no? It contains all the details about the floors, the doors, windows, etc. And based on these descriptions, we build the house, and house is the object. As many houses can be made from a house's blueprint, we can create many objects from a class. And an object is also called an instance of a class, and the process of creating the object is what we call instantiation. So, kaya dapat ngayon, medyo dapat familiar na kayo on how you, kapag ka na-mention natin yung instantiate, instantiation, so definitely, that is what we call, when we try to create a class or an object, ang ibig sabihin no, nag-i-instantiate tayo. Now, in defining the class, this was discussed a while ago, okay? Like functions, the definitions begin with the def keyword, right? But the class, it begins with the class keyword, okay? So the first, and then it follows, sorry, let me drink first, nasa mid ako. Okay, when we try to define a class, we are using the keyword class, and then it follows the name of the class. Okay, now you can see here you can see here a string, no, inside the class. This is what we called a document string, no, and it has a brief description about the class, no. It's similar to the function, no. When you create a function, you can also create a documentation string for your function. Although this is not mandatory, this is highly recommended, no. This is an example, no. A class creates a new local namespace, no. When we try to define the class, it creates a new local namespace where all of its attributes are defined. Attributes may be data or functions, no? So it can be an object or it can be a method. Okay, like in this case, this is the object and this is the methods that are created inside the class. All right. Now, as soon as we define a class, a new class object is created with the same name, no? And this class object allows us to access the different attributes as well as to instantiate new objects of that class. Like in this case, we have a class person. Okay, we have a class person here, you can see. Okay, and then we have a documentation string telling us that this is a person class, and then this is an object inside that class wherein the age is equal to 10. Okay, and then we define a method, no? We define an attribute inside this. All right, and then we instantiate by printing the age of the person, which is equal to, actually it's the output of this should be equal to 10. Now this one will give us the function, no? So when we try to print the person that greet, okay, when we try to print this person that greet, it will give us the location of where this class is. Okay, so you can see the output, this function person that greet. Okay, so the class is the person and greet is a method inside that, no? So when we try to create this, it is actually can be accessed in this particular memory location. This is a memory location inside my computer. It can be different in your computer. Okay, and then when we try to output this person that we use the documentation, no, this is a you remember the initialization method. This is now what we call the document method, no, wherein you can find whatever it is that you write here, it will print basically the documentation string, no? Like in this case, this is a person class because this is what written here. Okay, so when you try to add more information about this, for example, in this program, yan. So when you try to execute this, you will see that the change will happen here, and also you can see that the memory location is now different, no? So if we try to execute it once again, it will be different, no, from the other memory location. So there is no definitive or definite place or particular place in the memory location where the function person that greet is located at. Okay, now when we create an object, so this is how we can create an object. This is what we call instantiation of object to a particular class. Okay, so remember the terms, huh? We are creating an object. That means we are instantiating an object for this particular class, which is person. Okay, so the procedure to create an object is similar to function call. Okay, wherein we create an object and then the function call is by calling the name of the function and then the open and close parentheses. So definitely this will create a new object instance named Hari. So we can access the attributes of objects using the object name prefix. And the attributes may be data or method. And methods of an object are corresponding functions of that class. So this means since person that greet is a function object or attribute of a class, person that greet will be a method object, no, in this particular case. So this person that greet is a method object. Okay, so another example, so you can see here the same class, the same document string, the same object. Okay, and then we have a method here. Okay, so let's create a new person called Hari, because in this example above we don't have an object, no, that we have created. Now we have created or instantiated an object that belongs to the person class. Okay, and then let's try to output. So when we try to print the person that greets, so definitely this is a method of the class, no, and it belongs to this particular memory address. Now this one, okay, when we try to print Hari that greet, no, so definitely it will not tell us anything, but basically it will give us that whenever an object calls its method, okay, the object itself is passed as the first argument, no, as you can see from the explanations down here. But here, when we try to call the object's greet method using the object that we have created, okay, so this is the name of the object and this is the name of the method. So basically it will tell us hello, because the function hello is the function meant for the class. Okay, so by now you should be familiar with the class object, instance object, function object, method object, and their differences. So if I ask you to explain what is a class object, this is the class, or this is the object that we try to instantiate within the class. Okay, so that object is an instance object. Now when we try to define a method, that is what we call a function object. Okay, and basically it's also called method object. Okay, now aside from that, we need to understand also about constructors in Python, no? Class functions that begin with double underscore. Okay, remember this is important. They are called special functions, no, as they have special meaning. For example, okay, the init function, diba? When we declare an init function, okay, this special function gets called whenever a new object of that class is instantiated. And this type of function is also called constructors in OOP. And we normally use it to initialize all the variables. Like in this case, okay, we have a program here. We define a new class to represent complex numbers. Okay, it has two functions, the init or initializer function or method. Okay, and it initializes the variables, no? Initializes the variables. Like for example, the default of the variables is equal to 0. And we also have the function here inside, which is get data, which is to display the number properly. Okay, so we are defining what we call the number properly. So these are only definitions inside this initializer method. But initially, you can see from here the r, which is the real number, is initialized to 0, and then the imaginary number is initialized to 0 as well. Okay, now here, okay, you will see here that we created a new complex number object, no? And we instantiate an object called num1, and we call the function complex number, okay, or the class, and that means this object belongs to this class object, no? And then we instantiated two parameter arguments, which are 2 and 3. So basically dalawang argument to, no, r and I. which is 2 and 3 in this case. So if we try to call the getData method, no, because this one should print something like this, no, it should print the self.real and self.image, and then it will also add additional character here, which is j. So basically, ito yung purpose niyan. So the output should be something like this. Okay? 2 plus 3j. Okay? So when we call this, this should output 2 plus 3j. Okay? So to create another complex number object, we can add, for example, num2. Okay? So this object belongs also to the complex number class, but this time only one. Okay, isa lang yung ano natin, no? Isa lang yung kinreate natin na argument. So what will be the result if this is the case, no? Isa lang yung argument natin. So most probably makikita nyo rito sa baba, meron tayong mga error, no? Basically saan nanggaling yung error natin? It came from like in this case, complex number object has no attribute attr. Okay? Because here we call the function num2.attr. Okay? So basically dito magkakaroon siya ng error dito. Okay? And then when it calls this one num2.attr, it definitely will have errors, no, because there is no attribute attr according to the explanation, no, or comment of this example. So an interesting thing to note here is that attributes of an object can be created on the fly. No, we created a new attribute attr here, although we created this, okay, for object num2 and read it as well, but this does not create that attribute for object num1. Kaya nga pagdating dito, nung nag-print tayo dito, may error na. Actually dito, magpiprint pa siya, no? Yan, nag-print yung num2.real, okay? Because num2 belongs to this class. So, meron pa siyang real, meron din siyang imaginary. Pero itong num2 na to, which is equal to 10, nag-print pa siya. Kaya nga ang output ay 5, yung real, imaginary is 0, and 10 is the attr, which is equal to 10, no? Nagprint pa siya. But this one is only for num2 object. Hindi siya pwedeng magprint dito sa num1 because num1 is not associated with attr. Dito sa num1 na kinreate natin, wala siyang attribute na attr. Okay? Sa num2 lang tayo naglagay ng attr. So definitely dito lang tayo merong attr. Alright? So this is an example, okay, of how attributes can be given to any object. So this attribute is given to num2 but not given to num1. Okay, to num1, this one, this object. So basically, when you try to use the attribute of num2, although they belong in a similar class, they belong both to complex numbers, the attribute which is given to num1 will not be inherited or will not be transferred to num1, no, because it's only given to num2. Okay? Okay, how to delete attributes and objects, no? So any attribute of an object can be deleted anytime, no, using the delete or del statement. So try the following on the Python shell so you can see the output. So for example, if we try to declare num1 is equal to okay, so hindi natin ni-run to. So let's try to run this one first. So when we try to execute this, so num1 now is an object. Okay, so when you try to issue the num1, it will tell us that num1 belongs to the class complex number and belong to this particular location. Okay? But if you want to delete, no, since etong imaginary na to, 'di ba, from here, this is an attribute, no? Or actually, this is an attribute of the class. Okay? So here, we are trying to delete the attribute of num1. Okay? And then we try to use the function getData. Okay? So when we try to execute this, we deleted the imaginary number, but when we try to get the data, it gives us an error, no? Because we have deleted the the image, no, the imaginary number here. Okay, so this is how we can delete an object. Another example, let's try to delete the getData method. Okay, so ito naman, this time we're trying to delete from the class, we are deleting the getData method, no? So we can delete that. So when we try to execute num1, it will not run also. Why? Because we have deleted the attribute from here. Okay, so basically what we can delete objects. We can also delete attributes from a particular class. And we can also delete the object itself. Now, for example, C1. So let's try to make this C1 as a member of this class. And we put 1 and 3 here, no? But this time, okay, this time, we want to delete C1. Okay, so let's try to to create a cell above. So let's try to create this. So I will show you now what C1 is. So C1 is, C1 now belongs to the complex number. So if you try to, for example, if you try to use C1 that get data, okay, get data. So what is the okay, get underscore data. Okay, so you will see here, okay, okay, wala na siyang attribute kasi dinilit nga pala natin. So let's try to run this one again. Okay, nirun natin siya, and then we created this one, no, as a member of, as an object that belongs to the class complex number. So when we try to get the data, you will see here that the data that was the output of the execution will be to execute the method getData, which is to display 1 plus 3, and then mag-a-add siya ng j, which is 1 plus 3j. So basically, this is the real number, this is the imaginary number. Alright? Now, let's try to delete the object, no, na kinreate natin. Nag-create tayo dito sa taas, but this time, let's try to delete. Okay? So, let's try to delete. Okay? Nag-run siya, nag-delete na siya. But when you try now to see whether C1 is still there, you will see name error. C1 is no longer there. No, it's not defined because we already deleted. Although we have created the C1 before, we have created it here. It is now not being found. Okay, because we have deleted C1. Okay, so there are notes here. No, actually it's more complicated. No, when we do C1, a new instance object is created, and the name C1 binds with it. On the command delete C1, you will see this binding is removed and the name C1 is deleted from the corresponding namespace. And the object, however, continues to exist in memory, and if no other name is bound to it, it is later automatically destroyed. Okay, this automatic destruction of unreferenced objects in Python is also called garbage collection. Okay, so yan, automatically destroyed na siya lahat, whatever it is. Okay, now let's move on with inheritance, more about inheritance. So again, to discuss about inheritance, so definitely it refers to defining a new class with little or no modification to an existing class. Okay, so the new class that is derived is called child, and the one from which it inherits is called the base or the parent class. Okay, so this is the basic syntax. Okay, so basically it has an error here because actually these are not proper syntaxes, no? but definitely it tells us the body of the base class. This is the parent class, and this is the child class. So you will notice that the child has the name of the parent. That's the difference between the parent and the child. So they have both different names, but the name of the parent class is inside the parameter inside the child class. All right? So this is an example. Okay? So let's try to, so this is an example of an inheritance. So you can see from here, okay? This is the example on how we can define Python inheritance. This is an example of a program that defines inheritance. Okay? So this class that we created is what we call class polygon, no? Okay? And this polygon, we all know that a polygon is a closed figure, no? With definitely 3 or more sides. So let's say we have a class polygon and we have an initialization methods here. It tells us the number of sides, no? So self.n, okay, is equal to the number of sides, and self.sides is equal to 0 for I in range number of sides. Okay, so this one tells us how many sides do we have when we don't know the number of sides that is given, or when we don't know the given polygon, whether it is how many sides, no? So this class has the attribute to store the number of sides and the magnitude of each side. So this is the magnitude of each side as a list called sides. Okay? So the other side is to input the side. This is another method, which is to input the side. It takes the magnitude of each sides, okay, and then the display sides, display this side lengths. So these are the functions inside it. Okay, so you'll notice we have a for loop here. So for I in range self.n, self.n is the number of sides. Okay, so this will that means the for loop here will loop for a particular number of times in the number of sides that we have here. Okay, so basically another class that we have here is a child class, no? So this is the parent or the base class that we have, the class polygon. Let's run it. I already ran it. Now we have another class, and this class triangle belongs or inheriting the attributes of the class or the parent class polygon. Okay, that's why we have a polygon here. So here we define the initializer method. Okay, how many sides do we have in a polygon, no, in a triangle? So we have 3 sides in a triangle. Now we have another method here. This method is separate from the method here, no? What actually we are trying to see here is that when we try to print, okay, the number of sides and display the sides, we try to call, okay? Later on you will realize that this child will inherit the methods and the objects that belong to the class polygon. All right? So here we have some formulas or some methods on how we can take the actual number of sides. Okay, ABC is equal to the number of sides, and then we calculate the semi-perimeter, A plus B plus C divided by 2, and the area is equal to S, okay, multiplied by S minus A, multiplied by S minus B, multiplied by S minus C, multiplied by 1/2 or 0.5. So the area of the triangle is equivalent to 0.2F, and we're calling the variable area to display the result of the area of the triangle. Okay, now we try to run this one. So of course nothing happens because this is only a class. We did not instantiate an object yet. Now here we instantiated the object. No, the T here is the object. It belongs now to. Let's try to para makita ninyo. Let's try to create this here. Put it here and let's try to print where is this T can be found, no? Anong class siya kabilang? So you can see that the class belongs to the triangle class. And basically triangle belongs to the parent class, right? So if you want to see, this T object that we created now belongs to the triangle class, but this triangle belongs to the polygon class that we created. Now the input sides here is a function inside the polygon, no? The parent, it's inside the polygon class. Now ginamit natin yung function na yon using the object that belongs to triangle dun sa child. Have you noticed? We are using the child object using the parent method to display the number of sides. Can we do that? Yes, we can. That's the beauty of OOP and inheritance. Because this object, although it belongs to triangle class, but this triangle class belongs to the parent, which is the polygon. So basically, the triangle class inherits the functions, input sides of the child. So when we try to execute this, it will give us, for example, 25 is the side one, and the second one is 28, and the second one is 30, for example. So it will give us the number of sides, the following value. Side 1 is 25, side 2 is 28, and side 3 is 30. So display side is also a function or a method inside the class polygon, which is a parent class. But definitely, although T belongs to the triangle class, an object inside the triangle class, we can also use display sides. And of course, even if we use the T, no, the T find area belongs to this, no. This is the original function inside the class triangle. Of course, it will run, no. It will definitely run. Okay, so the area now is 326.05. So we can see that even though we did not define methods like input sides and display sides for the class triangle separately, we were able to use them, no? We were able to use these two functions, no? Although wala to dito sa triangle, nagamit natin siya because this triangle is inheriting the properties of the parent class. Okay, can you hold on? Okay, let's continue. If you have some questions regarding the topics, you can ask your questions anytime, ha? Para malinaw sa ating lahat yung dinidiscuss natin. Okay? So, are there any questions so far? Anyway, I will be uploading the module 4 notebook, so don't worry. You will have a notebook of this one so that you can use this notebook or for review or for your reference. Okay? Ano nangyari? Anong question to? What is this question? Is this a question? Yeah. I have a call earlier pero nung inaccess ko na siya, hindi ko na siya inabutan. So I'll just wait again because this is a meeting between some friends of mine because there is a alarming case of COVID outbreak in our area. So medyo mahirap. So I am hoping that everyone is safe from from the pandemic crisis. Okay? So let's continue, no? Malayo naman ako diyan sa nasa loob ako ng room, so I will not be getting out. Anyway. So let's I have already discussed this. So let's proceed with the method on how we can override method overriding in Python. Now, in the above example, you notice that the initializer method was defined in both classes, no? The classes triangle as well as the polygon classes, no? And when this happens, the method in the derived class overrides in the base class, no? This is to say that the initializer method here, okay, this initializer method in the triangle gets preference over the initializer method in the polygon. Okay, so generally when overriding a base method, we tend to extend the definition rather than simply replace it. So the same is being done by calling the method in the base class from the one in derived class, calling the polygon that initializer method, no, from the initializer method in the triangle, because we also have an initializer method here in the triangle. So a better option of doing this is by yung earlier example natin kanina, we can use a built-in function. We call it the super function. So super function, okay, super function can be used here, no? Actually, we can use a super function is also, halimbawa dito sa nakikita nyo rito sa method na to, we can also use super function dot double underscore init double underscore, okay, sobra yata ako ng underscore init, and then double underscore, and then we can also put here 3. So this one, this line number 3 is the same as line number 4. Okay? Okay, this one is, but this one is the preferred. Okay, this one is the preferred. Okay, actually, we can do this, but this one is the preferred, indicating that we are actually accessing the class, the parent class polygon, no? Okay. Now, to be able to know that, now we have some example on how we can actually check the inheritances, no? For example, if we want to check whether T is an instance of the triangle, so we can use the function isInstance. Okay, that means is T an instance of the class triangle? So pag niran natin yan, true, sasabihin niya. If is T an instance of the function or the class polygon? Ito yung parent natin, 'di ba? Yung function na yan, basically true pa rin yan, no? But is T an instance of our variable integer, for example? Sabi niya false. Is T an instance of an object? Sasabihin niya true.
Sir,
Okay?
nakamute po kayo.
Ay,
You are now unmuted.
sorry again, no? Ang hirap ng ganitong may mga ano tayo. So anyway, ulitin ko na lang, no? Ulitin ko na lang. I'm sorry again, no? This is the second time na nangyayari yan. Ang dami kasing mga nangyayari sa paligid namin. Very alarming, okay?
Sir, nakamute po kayo.
Nakamute again? Inano ko na siya. Okay na? Naririnig nyo na ako?
Okay na po.
Okay na. Okay. Thank you. Thank you. So, I was explaining about how we can use the method of overriding in Python, no? In the above example, okay, notice that the init function that we have here, or method, it is defined both in the triangle and in the polygon, no? Meron tayong init dito, meron din tayong init dito sa polygon, right? So the method in the derived class is this, since the triangle is the derived class, okay, it overrides the init method in the base class, no? So this is to say that the init class here in the triangle, okay, in the triangle, the init class in the triangle, it gets preference over the init class in the polygon. Okay? So when we try to override the base method, we tend to extend the definition rather than simply replace it. And the same is being done by calling the method in base class from the one derived in the derived class, no? For example, in this case, you can see, so ito, kakalagay ko lang to ha, let's say wala yan, no? So this one is the method to override the init method here, no, in the polygon class, in the base class. So this is also the same when we use the super function, using the init function, and then we just put, we don't use self here, no, because this is not a basic initializer method. So but definitely, sabi ng instruction, it's okay to use this type of method, no? This is the best option to do it, no? This is the most preferred, no, rather than using the super function. But if you want to know more about super function, definitely there are more Now, when you want to check the inheritances, no? For example, we have created T as an object of the class triangle, no? The term or the function is instance is a built-in function wherein we can determine whether an object is an instance or a subclass of a particular actually we can use it to check the inheritances, no? So for example, in this case, we can check that T is an instance of the triangle because the output is true. And T is also an instance of the class polygon because it's true. But T is not a class or an instance of the int. Okay? Kaya false yan. T is also an object, right? So definitely true siya. Similarly, is subclass is also used to check for class inheritance. For example, is polygon subclass of the triangle? Definitely false, no? Kasi it's the other way around, no? The triangle is a subclass of the polygon as denoted by the result, which is true. Is bool an inheritance or a subclass of the we call it the integer class, the integer data type classes? Yes, it says here true. So definitely we can use those when we want to check the inheritances. Okay? Now, we also have what we call Python multiple inheritance. So in this particular topic, we will learn the multi-level inheritance and the method resolution order. Okay? So a class can be derived from more than one base class in Python, no? It's similar to C++. This is what we call multiple inheritance. In multiple inheritance, the features of all the base classes are inherited in the child classes or derived classes. And the syntax for multiple inheritance is similar to single inheritance. So this is an example of that, no? For example, class base 1, class base 2, and then we have this is a derived class, no? A derived class coming from two classes, from base 1 and from base 2. So here we have a multi-derived class which is coming from the class base 1 and coming from the base 2. So this is the syntax for that. We also have what we call, this is what we call multiple inheritance, ha? We also have what we call multi-level inheritance. So ano naman yung multi-level inheritance? So para mabilis, makikita nyo that this is like a hierarchy, no? So this is the base. No, parang ito yung pinaka-parent, and then we have a child, derived 1. Tapos nagkaroon ng child si derived 1, tinawag natin siyang derived 2. This is what we call multi-level, wherein the level here inherits the properties here, and this one inherits the properties of this particular class. All right, so this is an example of that. So let's say we have the following example. We can print is list a subclass of an object. Sabi niya true. Is 5.5 an instance of an object? Sabi niya true pa rin. Is hello an instance of the object? Yes, sabi niya pa rin hello. So basically, ito po yung mga concept in object-oriented programming. Now, all you have to do now is to practice, no? Search the internet and look for problems that involves object-oriented programming. Okay? There are plenty of exercises in the internet that you can use. Do not rely on my lecture alone. Okay? My lecture will help you, can help you. But definitely, it is not enough para ma-perfect ninyo kung paano yung running all about the programming of object-oriented programming. In our last topic here, we have what we call the we have here what we call the multiple inheritance scenario. Okay, wherein we can search the first in the current class. If not found, the search continues into the parent class in def first, and if it is not found, then it will say it's false. No, so in this above example, the multi-derived class search in the order of multi-derived, and then base 1, and then base 2, and then the object. So this is also called linearization of multi-derived class, and the set of rules used to find this order is called method resolution order, or MRO. So if you would like to know about MRO, so there is a separate function for that, MRO. So this is the multi-derived function, or this is the function that we created here. So you will see here that the MRO, you will see the different classes, no? Like the multi-derived, it belongs both with base 1 and base 2, and then the object. Okay, so you can also use, it's either you use double underscore MRO double underscore, or MRO function, or this parentheses. All right, so you can see here where if you just want to know the different classes that you have created, no, para makita nyo, halimbawa nag-create kayo ng classes, tas nalilito kayo kung alin doon yung parent or kung alin doon yung mga derived classes, you can use the method of what we call the MRO, or the method resolution order, in order for you to determine saan ba galing yung method na na-derive mo. Okay, this may be a different name, this may be a different name, but most probably when you use this method, it will display all the different classes, no, wherein kung saan mo na-derive yung function na yon, no? Let's say for example, in this case, dito sa taas meron tayong polygon at saka asan na ba yung polygon natin at saka triangle natin dito. So we have here, okay, so we have the polygon. Let's try to run the polygon and the triangle. So let's try to create another cell above, okay, and let's try to check polygon dot, and let's try to use MRO function, no. So you can see that polygon is the name of the base class, no. Wala siyang ang method resolution niya lang object, no, object. Ito lang yung output niya. kasi hindi niya, ito kasi yung base natin base. Pero kapag ka sinubukan natin yung triangle, dito makikita nyo kung saan siya na-derive. .mro. Yan. Makikita natin siya kung saan siya na-derive. See? This is your class triangle and dito siya na-derive sa polygon. Okay? So, yan yung gamit ng method resolution. No? In order for you to see or check kung saan nanggaling yung mga classes natin. So, that's the end of our demonstration and topic for this afternoon. If you have some questions, I'll be willing to answer your questions. Do you have any questions?